Gentlemen, thank you for the invitation. My name is Antonis Kalemis, and I will present today the innovations in the molecular imaging portfolio that we have at Siemens. Starting from the PET-CT family, we have three systems: the Biograph Horizon, the Biograph MCT, and the Biograph Vision. All three systems utilize crystal material, LSO, which give superior time of flight. They come with the options of HD PET, and which is the PSF reconstruction algorithm, and the combination of HD PET with time of flight. They have all innovative CT technologies and a bed that minimizes deflection. They come with high resolution imaging, ability to automate the quality control of the system, and also innovative motion management techniques. The Biograph Horizon and the Biograph MCT are based on our traditional Optiso HD detector, which is 4 by 4 millimeter by 20 LSO crystals coupled to photomultiplier tubes, giving the best performance for photomultiplier based systems of 540 picoseconds timing resolutions for time of flight. On the other hand, we've got the Biograph Vision, where we have the Optiso UDR detector technology with 3.2 by 3.2 by 20 millimeter LSO crystals, the finest crystals in the market, coupled to SIPM detectors, silicon photomultiplier detectors, giving the best timing resolution in the market today, which is 214 picoseconds. The other distinction is on the bore size and the CTs that are utilized. The Biograph Horizon has a 70 centimeter bore size, and it comes with 16 or 30 slices CT, and it's an air cooling system. While the Biograph MCT and Visions have 78 centimeter large bore, the only 78 centimeter bore of the market. And they come with 40, 64, and 128 slices CTs, and they are water cooled. Our latest addition is the artificial intelligence platform, which comes as an option to all our family. And this comes with different artificial intelligence powered options that I will present the most important ones later. Before going into the AI, I'd like to present what is the signature feature of the Siemens PET-CT systems, and that is the ability to perform a continuous bed motion instead of the traditional step and shoot mode. What the continuous bed motion offers is the ability to have a better patient comfort, to do faster scans, and to simplify the patient or the scan setup, which enables to reduce the probability of making mistakes as well from the technologies. This also integrates all the different requirements for scanning, different speeds, or whether they need motion management in one of the segments into one single protocol that can be selected and with one click of a button. The addition on this technology is now the ability of having an artificial intelligence algorithm which defines from the CT imaging where the different parts of the body are for every single patient that you have on the table, and this makes it even easier for the scan setup. So now you only have to run the CT and press the button for acquiring a specific protocol, like here the whole body head and neck protocol, and the algorithm, the system will understand what the patient habitus which is on the table, and it will adjust the protocols and the ranges accordingly. Another innovation is in the area of motion management for a respiratory motion. We have recently introduced the OncoFreeze AI, which is a deviceless motion management technique. You can reconstruct before or after the acquisition and without extending the scan time. It comprises of the alpha technology, which is the artificial intelligence component that understands which part of the body suffers from motion. Then we extract the waveform without device from the PET raw data, and we utilize the waveform for the OncoFreeze part, which is an algorithm, an optical algorithm that will identify the motion in different frames and will correct for that, resulting into one single image in having 100% of all counts that have been acquired. And again, all of these without having to extend the scan time of the scan. This is an example of how OncoFreeze AI looks like. So here we've got a lesion where with OncoFreeze it becomes much more apparent that it's there. It has better delineation and better intensity or contrast. The last feature that I would like to highlight in my presentation is called Quality Guard, and it's automating the daily QC. So we utilize the LSO background radiation that the crystals have, and we use that to self-calibrate the system. Quality Guard runs daily quality control procedures automatically during the scanner off hours, and it streamlines workflow. There is no need for radioactive calibration sources anymore. It reduces the staff exposure to additional radiation, and it eliminates the work of lifting heavy phantoms for performing the quality controls. Moving now into our Spect and Spect CT portfolio, the main thing to note here is that all our Spect and Spect CT system are underlined by the same core technology for Spect across the entire product portfolio. So all systems have the HC detectors with autoform collimators, which are collimators that Siemens produces ourselves. It has high sensitivity and the finest reconstructed resolution of the market, and also it has the best detector flexibility for patient positioning. Having said that, we now have systems that have additional features, like, for example, the automatic collimator changer, the automatic quality control, and the very innovative feature of doing cardiac SPECT. The Spect CT systems are divided into the Symbia Intivo XL, which is a low-dose Spect CT for attenuation, correction, and localization. We've got the Symbia Intivo 2 and 6, which has a fully diagnostic CT with 2 and 6 slices. And we've got the Intivo Bolt, which comes at 16 and 32 slices with all the novel CT technologies like iterative reconstruction, metal artifact reduction, and dual energy acquisitions. Last but not least, the last part of the portfolio also is enabled to utilize the Spect technologies, which is the unique technologies that Siemens introduced, and they improve image quality and quantification for Spect. One of the main features is the automatic quality control, where the source on a rod will come out automatically overnight, and it will do the quality control, the daily quality control for the system itself, without having the personnel to bother with this. So the system is ready for patient scans in the morning. Another feature is the automatic collimator changer, where with one click you can change up to 2 collimators stored under the bed, and this eliminates the variability from manual handling. It lowers the risk for equipment damage, it conserves space, and it saves up to 5 minutes per each collimator exchange. From the CT side, as I said, we have iterative metal artifact reduction technique. We have the iterative reconstruction for CT, the ability to go up to 32 slices CT, and also to be able to visualize differences with dual energy CT. This is an example of the IMAR where the beam hardening has been eliminated by utilizing the iterative metal artifact reduction technique. We have an option which is called IQ Spect, and this is a technology that minimizes dose and maximizes speed for cardiac scans. It's comprised by a unique magnifying collimator pair, the smart zoom collimators. This is coupled to a cardiocentric acquisition where, irrespectively of the body size, the heart is always kept in the middle, so we move away from the static 90 degrees cardiac acquisitions. And then we've got also an advanced reconstruction scheme that utilizes the information and produces superior image quality. This is an example where, as you can see, the standard acquisition that takes 16 minutes can be reduced down to 4 minutes, keeping the image quality at the same level. So we go 75% faster in cardiac scans. Last but not least, we've got the Spect technology, which integrates multiple corrections for better image quality and up to 5% quantitative accuracy. Standard technologies like the PSF reconstruction can be utilized in there, attenuation correction, but we also are able to calibrate the camera for the for quantification, and we also are able to utilize information from the CT regarding the specific radio trace that we use in Spect. This is an example of one of the Spect applications called Spect Bone. This is for MTP bone scans only. And you see here when it's compared to Flash 3D, which is our iterative PSF enabled reconstruction, you see the superior image quality and delineation of the lesions that come with this extra technology by utilizing the additional information of where the bones and the lesions are from the CT scans. Finally, this is the Spect Quant technology where we bring SUV quantification from the PET world into Spect, and this is an example with lutetium 177 dotatate, where, as you can see in the images, we go away from the counts and we can produce very accurately SUV values for those acquisitions. And this is available for lutetium, indium, iodine 131, iodine 123, and technetium scans. Thank you very much for your attention.